Now, if I get the substance from this tray over here, it would also be considered matter. It's not energy, so it's matter, which means it's made up of tiny particles we call atoms. Now this turns out, there's no way for you to know it unless I told you, but this turns out to be made up of only one type of atom. If I were to break this up into its individual atoms, I would find out that all the atoms look exactly the same. There's only one type of atom in here. Because there's only one type of atom, we call this an element. An element is only one type of atom. Now, I know this analogy may be a little bit silly, but it's very similar to having a structure of Legos. If I were to take these Legos and break them apart into their individual particles, not that one because that one doesn't work, and I take this and break it up into its individual particles, and I look at each one, they all look exactly the same. So this here, this structure, we would consider an element because it's made up of only one type of Lego, just like those elements are made up of only one type of atom. One type of atom, it's an element. Two or more, what we're going to call it is a compound. Now, this word compound has at the beginning of it a prefix, co. So it's like in football when you send out more than one captain, we call them co-captains. When you get on the airplane and there's more than one person flying the plane, we call them co-pilots. When you're at Taco Bell and you're in charge of putting the tortillas down and your friend's in charge of putting the beans on, you call it a co-worker. Okay? When there's more than one, we use the prefix co. The problem is, the word compound, you don't hear the co part. So it's easy to forget that the word compound means two or more. So in this class, we'll call it a co-compound. So that way, no. But sometimes, just to remind you, I will pronounce it that way, co-compound, instead of compound. So that co means two or more. So for instance, if we have a substance that has two or more types of atoms. For instance, water. Another name or another way we can recognize water is by calling it H2O. Now, all of a sudden, the rules have changed. No longer is there one type of atom in there. Now there are two types of atoms in there. And so we don't call this an element, we have to call it a compound. Because there's two or more. Now, these elements are listed on the periodic table for us. And that's why it's called the periodic table of the elements. There's 117 in there. What I want you to notice is the last one is number 118. And then number 117 is blank. There is no number 117. So even though we end on 118, there is only 117 because there is one missing. This is a list of all the elements in the entire universe. It's right here, sorry. So we got these two extra rows on the bottom. And then these guys later will learn that we have to shove these guys up into the periodic table, and the periodic table should extend, but they don't like putting it that way because then it's very awkward. It's very, very long and skinny periodic table. So they pull these two rows out and shove them to the bottom. And so the last one listed is actually right here, number 118. It turns out that of all of these elements, 90 occur naturally. So, depending on how you want to think of the universe and how it was made, in my mind, when God made the universe, He made 90 different types of atoms, which we call elements. Then, since then, specifically within probably the last 100 years or so, scientists have figured out how to create or produce new atoms. a lot of times they will take existing atoms, getting going very quickly, and bombard them together to make new atoms. All of these open boxes, these ones that are in the outline, are man-made. And so right now there are people that wake up in the morning and go to work, and their whole job is to try to create or make number 117. They haven't been able to do it yet. Now, this thing, well, this was produced back in 1998, this chart, and you can see here that number 113 as well as number 115 has been made in the last couple of years. I don't know exactly when they were made. You could look them up and find out. So I had to climb up here and write UUP and UUT. The U stands for 100. The next U stands for the next tenths place. So 100 and then 10, and then the U here stands for UN, which stands for 1. The B stands for bi, which is 2. The T stands for 3. Q stands for 4 for quad. P for pent for 5. Hep for 6. And then O for the 8 guy. I don't know what they'll do for him because hex is another H, so they'll have to pick another letter. These down here don't have official names yet. They don't know exactly what to call them. So, for instance, at the University of California at Berkeley, they produced this or created this. I don't know what year it was. But they made that guy. So they got to name him. So they called him Berkelinium. And then the CF. CF was also at California, Berkeley. And so they called it Californium. They got to name it. So whoever makes it first gets the naming rights. So this guy is Einsteinium. They named it after Einstein. And so 90 of these occur naturally in the universe. And then 27 of them are man-made, which adds up to the total of 117, 118, subtract the missing one. Now right now we don't know yet what's different about one atom versus another atom. You probably had a preview for this in junior high. But underneath there, 2 notes. 90 elements occur naturally. 90 elements occur naturally. 27 elements are man-made. 90 elements occur naturally. 27 elements are man-made. And then there's a few notes for the bottom. Just to remind you, an element is one type of atom. An element is something that only has one type of atom in it. Whereas a compound, 2 or more elements bonded, stuck to, connected with, together. 2 or more elements bonded together. Lots of different compounds. But now, instead of shaking this substance apart and seeing how many different piles, instead of shaking the water apart, how many different piles, instead of shaking the salt apart, how many different piles, if I take her and shake her apart into her individual little atoms, how many piles would I get?
Like 50.
A million.
Now be careful, when you say a million, there's only 117 that exist.
90.
Millions and millions of atoms, but how many different piles of atoms? What I'd like you to do with your partner is put a box around each element on that periodic table that you know for sure makes up your body. Alright, please take a look. Everything in the universe has to be either matter or energy. As you found out in this class, we're focusing on matter. All matter is composed of tiny particles that we call atoms. And then what we focused on was a substance that has only one type of atom, we call it an element. But if we've got 2 or more types of atoms, we call them compound. And you see that at the end of each tool as well.